Hello friends, we are discussing the fundamental forces in nature in the chapter Laws of Motion. And in our last lecture, we have discussed about the gravitational force, the Newton's law of gravitation in the gravitational force. And today we are going to discuss about the characteristics of the gravitational force, how the gravitational force actually is. So first characteristic is it is an attractive force. So there is only one type of force in the gravitational, it is only attractive. There is no repulsive forces. So all the bodies in not only are in and around the earth, but I am talking about the universe. अख्ख्या ब्रह्मांडाबद्दल बोलते मी. अख्ख्या ब्रह्मांडामधल्या सगळ्या all and all bodies of the universe are attracting each other by the gravitational force. Such is the range of the gravitational force. Its range is unlimited. Its range is the whole universe. So it is unlimited range. The gravitational force is the weakest force in nature. The next is it is all applied for all the macroscopic and the microscopic bodies. That is, in the universe there are so very huge bodies and there are very small bodies and very small bodies, right from the amoeba, like very small bodies, like from the atom to the molecule and the living amoeba. So all the microscopic bodies and all the macroscopic bodies like the earth, sun, moon, and all very big bodies, they are attracted to each other. No medium is required. Is there any medium between the sun and the earth? No, there is only space. So the gravitational force, when the gravitational force is existing between any two bodies, there is no requirement of the medium. It obeys inverse square law of distance. Now we know that according to the Newton's law of gravitation, the gravitational force F is equal to G m1 into m2 upon r square. So this is inverse square law. The more as this r increases, F decreases. So as the distance between the two bodies increases, the force between the gravitational force of attraction between the two bodies decreases. So it obeys inverse square law. Now this is the very important characteristic that the whole universe, the earth, the planets are revolving around the sun. The universe, there are so many suns in the universe, and there may be so many planets. There may be natural satellites, like we have, our earth has moon. So there may be satellites, natural satellites to the planets, and the stars like sun, like our sun. There are so many stars. So the structure of the universe, the structure, each one is rotating about the other. The gravitational force governs the structure of the universe. The second most important fundamental force in nature, or the real force in nature, is the electromagnetic force. Forces between electric charges in relative motion are the electromagnetic forces. The force which holds together the atoms and molecules of a body is the electromagnetic force. We would discuss about the characteristics of the electromagnetic force. This force is related to the electrically charged particles. The next is, this force is of two types. It can be attractive force like gravitational force, or it can be repulsive force. Like when two like charges, the positive and positive charge, come near each other, then there is repulsion. And when the positive and the negative charge approaches each other, there is attraction. So it is of attractive nature and also repulsive nature. It is stronger than the gravitational force. Gravitational force is the weakest force. It is the most important, but it is the weakest force in nature. But the electromagnetic force is stronger than the gravitational force, but it is weaker than the nuclear force, which is the strongest force in nature. It The electromagnetic force also obeys the inverse square law, like the gravitational force. It depends on the electromagnetic force depends on the intervening medium. What is the medium? It depends upon the medium. It is a long range force. Also, we would be discussing some examples of the electromagnetic force. Now, force of friction is electromagnetic in origin. When my this hand is moving on this hand, when the motion is in this direction, there is a frictional force which is exerted by my this hand on this hand exactly in the opposite direction. Frictional force opposing force hai. When a body is in motion, the frictional force is exactly opposite to the direction of motion. So, this frictional force is electromagnetic in origin. The next is the normal reaction. When I am standing on this floor, my weight is exerted in downward direction from my center of gravity point in the downward direction. It is exerted on the floor, and the floor is exerting a normal reaction on me, and hence I have a feeling of weight. So this normal reaction is also electromagnetic origin. The next is tension in the string. We have seen in the conical pendulum that the string, it has tension. I have to hold the string. So there is a tension in the string. So this tension is also in the string is also electromagnetic force in origin. The collision force, that when two bodies are colliding with each other, again this is electromagnetic in origin. The elastic force, we know that there are some elastic bodies. The metals have elasticity. So the elastic force is also electromagnetic in origin. And the viscous force, like the frictional force which is for solids, it is the opposing force in solids. Similarly, there is an opposing force in the liquid also. That is, when one layer of liquid is moving over the other layer, there is an opposing force which is created opposite to the direction of motion of the liquid layers. So, such opposing force in the liquid is, which is the viscous force, is also electromagnetic in origin. Under the action of these forces, there is deformation of objects that changes the intermolecular distances, thereby resulting in reaction forces. The next force is the strong nucleus. Is the strong nuclear force. This is the strongest force, strongest fundamental force in nature, strongest real force in nature, which binds the nucleons inside the nucleus. We know that the nucleus, the diameter of the nucleus is also very, very small. Its range is nearly 10 to the power minus 14 meters. So small is the diameter. And inside such very small nucleus, there are the neutrons and the protons which are positively charged. And we know that two positively charged particles repel each other. But still, inside the nucleus, the protons and the neutrons are in stable condition. Inside the nucleus, there are the protons and the neutrons. They are binded to each other by the strongest force in nature, that is the strong nuclear force. Protons repel each other according to the Coulomb's law of charges, and hence to hold these protons and neutrons to overcome the repulsive forces between two protons, there is a very, very strong nuclear force. This very strong nuclear force holds the protons and the neutrons inside the atoms and makes the atom stable. Fission reaction this nuclear force played a very important role. We know that in Hiroshima and Nagasaki in Japan, the atom bomb was dropped. This atom bomb and vast devastation was done in within very short time, within seconds, by this atom bomb, which is the nuclear force, the very strong nuclear force is the base of this atom bomb. This nuclear force plays a very important role in producing the nuclear energy by the fission and the fusion reactions. The characteristics are, this force is only attractive type in nature. There is no repulsion anywhere. It is only attractive force. The strong nuclear force is attractive force. And though it is the strongest force in nature, its range is very, very small. Its range is less than 10 to the power minus 14 meter. It is, the force is limited to the nucleus only. This force is charge independent. The nucleons attract each other, whatever charge they may be having. They may be having positive charge, or they may be like proton, or they may be having no charge, that like neutron, or there are many more particles inside the nucleus. So this nuclear force is charge independent. Whatever is the charge, the particles are attracted to each other. It does not obey the inverse square law of distance. So such is the strongest force in nature, that is the nuclear force. The nuclear force is the base of the stability of the atom. There is one more force related to the nucleus, that is the weak nuclear force. Weak nuclear force is the interaction between subatomic particles, due to which there is the radioactive decay from the nucleus. Characteristics of the weak nuclear force are, this weak nuclear force is stronger than the gravitational force. The gravitational force is the weakest force, but it is weaker than the forces which we have studied, that is the electromagnetic force or the strong nuclear force. The next is the range of the weak nuclear force is very, very short, shorter than the strong nuclear force. Its range is up to 10 to the power minus 16 meter. So this force holds up till 10 to the power minus 16 meters only. So very short range force. And also it acts between two elementary particles. So today in this lecture we have discussed about the fundamental forces in nature, the real forces in nature. Thank you.